All right, guys. Now we're deep in the game. You should recognize this. We're going to really quickly take a look at go back to our food webs. Remember what we did last week with our pyramids, but we want to revisit. And I've read your exit tickets, and a lot of you had the right idea, but some of you had a few mistakes or erroneous ideas. So remember. Here's we're going to go back and use Mono Lake, showing all the feeding relationships and who eats what. Now remember, we worked on trophic level pyramids that you can organize each critter as far as where it goes, or excuse me, put it into places based on where it eats its food. Producers make their food, primary consumers obviously eat the producers, and so on and so on. Now, you might be asking, well, why does it matter what level you're at? But that's what we had started to look at. I want to clarify today. So remember, in terms of biomass, the amount of food, and ultimately from our reading the last several classes, we've realized that only a small fraction of biomass of food and therefore of energy is available at the next level. And notice they've said here about 10% of the biomass consumed as food at one level transfers to biomass in organisms at the next level. Well, what the heck does that even mean? So if we go back, what we're really saying here is that for our brine shrimp, if they were to eat, let's say, 100 grams of algae, they would only store about 10% of that. So they would only store about 10%, 10 grams in their bodies. And you want to ask yourself and think about, you may already know the answer. Well, where does the rest of that biomass, that energy go? So that 10% rule, and here's our answer as far as why. About 90% of the biomass used, that food, the molecules, is broken down and turned into energy, maintenance, movement, waste, all the stuff we've been saying, right? And then some of it's even lost as thermal energy, as body heat. So almost all of that food that they eat gets used or lost. Only about 10% gets stored in their bodies. And we call that our 10% rule. So what we can see in this, actually, if you start to think about, wait a minute, with our pyramids and our last exit ticket, that if we have all this energy at the bottom, that energy is reduced by a lot as we go up. So only about 10% of any energy here is stored here. Now think about, if we keep going, only 10% of the energy here is stored here. And only 10% of the energy here gets stored here. So that is why we have that pyramid shape. In terms of everything gets smaller and smaller as we go up. The base of our pyramid will have the most energy, will have the most biomass, will have the most numbers of organisms, and everything decreases, remember, as we go up. So just to think about that in terms of what we've been saying, could you have an ecosystem where 100 kilograms of algae, 100 kilograms of brine shrimp, and 100 kilograms of California gulls, even amounts? And the answer is no way. So think about, why not? Everything has to decrease. If we had 100 kilograms of algae, that could only support about 10 kilograms of brine shrimp, which in turn could only support about 1 kilogram, which is about 2 pounds of gulls. So you're going to need hundreds of kilograms of algae floating on in the water just to support 10 kilograms of shrimp to support 1 kilogram of gulls. That's why our pyramid decreases as we go up. So I remember we had created a model, because it's hard to think about that, and the fact that it takes tons of brine shrimp and flies to feed just one gull. So when we went back and using that idea of the 10% rule, we saw that in our models, remember. So I've chosen one here just to use quickly of the hot desert. Some of you used that last class, and notice that in terms of numbers of organisms, we have tons of different producers, and our numbers of organisms decrease as we go up. That's why you're not going to find tons and tons and tons of top predators. There are only a few, because it takes so much food to support them, and it takes so much food to support the heterotrophs, and it takes so many producers to support them. So if we could toggle back and forth our numbers, or our biomass, the amount of food, or our energy, always decreases as we go up. And the main reason for that, again, is our 10% rule. Really, really simple. Most of the food that gets eaten, think of it this way: if all of our primary consumers right here were to eat every last single drop, speck of producers, most of that food and energy would get used and lost. Only about 10% would get stored in their bodies. So there's not enough to go around. You cannot have a one-to-one relationship. So remember, 90% of that is used and is lost. Pretty simple. So if we go back, we can answer our questions again. So what I'm going to ask you to do is to take this idea of this 10% rule now and going back here in terms of our food webs, and we're going to apply that to an exit ticket. One of our friends is going to have something to say.